Hi, in this video, I will be showing you problem number 17 of chapter 16, section 4. Use Green's theorem to find the work done by the force f of xy equal to x times x plus y I plus x y square j in moving a particle from the origin along the x-axis to 1, 0, then along the line segment to 0, 1, and then back to the origin along the y-axis. So we are asked to apply Green's theorem. In this problem, we are asked to find the work done. So let's first see what Green's theorem is. Let C be positively oriented, piecewise smooth, simple closed curve in the plane and D be the region bounded by C. If P and Q have continuous partial derivatives on an open region that contains D, then integral over C P dx plus Q dy equal to double integral over D partial derivative of Q with respect to x minus partial derivative of P with respect to y dA, where f is pi plus qj and the line integral over cf dot dr is integral over c p dx plus q dy. So work done, we know that is in moving a particle is integral over c f dot dr. Work done by the force field F. So that is integral over Cf dot dr, which is also same as integral over Cp dx plus q dy, where C is as shown in the following figure. So it's the force field moves the particle from the origin to 1, 0 and then to 0, 1. So we mark the line segments, directed line segments as C1, C2, C3 as shown here. Then the particle moves along C in the counterclockwise direction, which is also known as positive orientation. Thus, by Green's theorem, we can say integral over C f dot dr, or work done, is equal to x times x plus y dx plus x y square dy. So here P is x times x plus y, which is x square plus xy, and Q is x y square. So dou P by dou y, a partial derivative of P with respect to y is x, and partial derivative of Q with respect to x is y square. As we are going to apply Green's theorem, we need the domain. We will see what the bounds for the domain. So we have the triangle which is connecting the point 0, 0, 1, 0 and 0, 1. Then D is the domain which is the interior. So we need the equation of the lines. We call the vertices 0, A, B. Then equation of line AB we can find out by getting its slope first, which is negative 1. Then using the formula y minus y1 equal to m times x minus x1, we get y equal to 1 minus x, which is the equation of line AB. So W is integral 0 to 1 for x, and then integral y equal to 0 to 1 minus x, then the integrand is y square minus x, and then you integrate with respect to y first and then followed by integration with respect to x. So w is integral 0 to 1. You integrate with respect to y, so y cube over 3 minus xy between the limit 0 and 1 minus x dx. So w is integral 0 to 1 minus x the whole cube over 3 minus x times 1 minus x between the limits. So we already applied the limits, so we have to integrate with respect to x now, which is negative 1 minus x to the power 4 over 4 times 3 minus x square over 2 minus plus x cube over 3 on integration between the limit 0 and 1. So if we compute the limit, it's negative 1 half plus 1/3 plus 1 over 12, which will reduce to negative 1 over 12. So can the work done be negative? Yes, it can be if the force has a component in the direction of the in the direction opposite to that of the displacement, then the force would be negative. The force does the negative work. So if the force has a component in the direction opposite to the displacement, then the force will do a negative work. Hope this video helps.